Okay, so we're going to talk about the first section, which is section 1.1, displaying distributions with graphs. Distributions with graphs. And we're going to talk about a couple just kind of important vocabulary terms to begin with. And the first two important terms are individuals and the idea of a variable. And individuals are, when you're doing something with statistics, it's the objects of data. Objects described by a set of data. Of data. And the variables are any characteristic of an individual. So for example, if you're looking at students and you want to figure out the average GPA, for example, of a bunch of high school students, the individuals would be the high school students, the variables would be their GPAs. If you wanted to figure out, you wanted to look at the number of sales at various McDonald's restaurant franchises, the individuals would be the restaurants, the variables would be the number of sales. If you want to do some study of hair color for kindergartners, the individuals would be the kindergartners, the variable would be their hair color. So you want to look at average number of tomato plants grown for different tomato plants. Well, the individuals would be the tomato plants themselves. Variable would be number of tomato plants. Here we go. So variables come in two different categories. You've got categorical variables. Categorical variables. And you've got quantitative variables. Quantitative variables. And the distinction is pretty simple. Categorical variables are not a number, whereas quantitative variables are numbers. So for example, think about just any one person. Like, what are some quantitative variables? Their weight, their height, the amount of money they have on them, the length of their earlobe, right? The number of arms they have. Anything that has to do with a number. What are some categorical variables for some student? Well, hair color, eye color, city they live in, last name. Anything that's not a number is a categorical variable. Anything that is a number is a quantitative variable. So an important term we're going to look at all year really is the term distribution. Distribution. And it's a really important idea we're going to look at over and over again. Distribution really just means what values a variable takes and how often it takes them. So we kind of use this term like this. What is the distribution of SAT scores of the senior class? What is the distribution of eye color of the junior class? So when you think about that term distribution, it's a really kind of just general term. And when you think about it, we're not going to say like the distribution is 14 or the distribution is big. To describe a distribution really you can't just do with like one word or one number or anything else. You have to figure, it's difficult to describe. If I asked you to describe the distribution of SAT scores of the senior class, not just one number can kind of capture that idea. So usually when we talk about describing a distribution, what we really do is we use some sort of graph. And really a big part of section 1.1 is a lot of different graphs that will help us describe a distribution. So let's look at a few. I'm going to give you a big list now of all the different kinds of graphs we're going to look at. Kinds of graphs all throughout chapter 1. And these are all kinds of graphs we can use to describe a distribution. I'm going to give you the complete list right now. We're not going to get to all of these in this lecture, but here we go. So there's just a big complete list of graphs that you will know by the end of chapter 1. Number 1 is a pie chart. Number 2 is a bar graph. Number 3 is a stem plot. Number 4 is a dot plot. Number 5 is a histogram. Number 6 is a time plot. Number 7 is something called a ogive, which we're going to look at in a little bit later on. Number 8 is a box plot. And the last one, number 9, is something called a modified box plot. And again, we're not going to look at all of these in this lecture, but we're probably going to look at the first 5 or so. Okay, so we're just going to kind of, the next little bit, we're going to run through these kind of graphs one at a time and kind of talk about how to make them and kind of, why they're important. So I'm going to start with the first 2, which actually are pie chart and bar graph, because they're related in one sense in that these are the 2 that you will use only for categorical data. If you've got quantitative data, you're not making a bar graph. Okay, so let me just kind of let's just make up some categorical data right now and talk about how you might make a pie chart and a bar graph with that. One thing that's going to be important for all graphs on the AP exam is you always look at the number of underlines. It's a lot of always. Always must label your axes. Okay, that's a kind of a common way to lose a point on one of the AP stat tests is to forget to label your axes. So let's make up some categorical data and go ahead and make a pie chart and a bar graph for that. So the categorical data I'm going to use is for a fictitious class, city you live in. Okay, city of residence. So here we go. Let's just say you've got some class, and let's just say in that class you've got in Menlo Park. Menlo Park is the hometown for, come on arrow, 7 people. Redwood City is the hometown for 5 people. Atherton is the hometown for 4 people. San Carlos is the hometown for 3 people. And you got 1 person living out there in Half Moon Bay. Okay, so that's categorical data. Now, why is that categorical data? Because city you live in is clearly a category. It's not a number. So how would you make a bar graph for that? Well, pretty straightforward. You draw in a little axes. And on the x-axis, you do which city you live in. So we got some categories there. The categories go on this axis. So we would go Menlo Park, Redwood City, Atherton, San Carlos, and Half Moon Bay. We always remember to label our axes, so this is city. And pick some reasonable scale. I'll go by 2s on the y-axis. So we'll go 2, 4, 6, 8. And then that's just going to be a number of people. And by the way, a little kind of thing, number of things or number of counts is a term you're going to see over and over again. We use the term frequency. Frequency means number of people. So we could have labeled the y-axis frequency. That would have been fine. And then we just draw bar graphs. So there's about 7, there's about 5, there's roughly 4, there's 3, and then there's 1. And that's a bar graph. One important thing to realize, in this case it looks like they're all going down. Notice that for any kind of bar graph, the x-axis is always categorical, right? And one way to think about that is that these cities are really in no particular, there's no really reason I put Menlo Park before Redwood City, before San Carlos. You could put Half Moon Bay over here and the bars could be all over the place. When you think about a bar graph, the things on the x-axis can be in any order. And that's going to become important later on because there's another graph that looks a lot like this called a histogram. And the main difference between a bar graph and a histogram is that in a bar graph, the x-axis is categorical. When we get to a histogram, the x-axis is going to be quantitative. Okay, so let's use the same numbers and talk about a pie chart. I'm not going to do much with it, but here we go. So for a pie chart, again, only used only used for categorical data. Basically, our numbers again, let's remind what they were. Menlo Park was 7. I'm forgetting what they were. I think Redwood City was 5. Atherton was 4. San Carlos was 3. And Half Moon Bay was 1. Okay, those aren't the same numbers. It's okay. Well, how many total people were? Let's see. 7 plus 5 is 12. Looks like I got 20 people total, right? Is that right? 7 plus 5, 5 plus 9. Yeah, 20 people total, okay? So basically for a pie chart, you just make a big old pie, a circle, and you figure out, well, how big would the Menlo Park pie be? Well, it'd be, basically in terms of degrees, it would be Menlo Park. How would you figure out how many degrees this would be? Well, it would be 7/20ths of the whole circle. We know that a whole circle is 360 degrees. You could kind of figure that out. Okay, it ends up being, let's see, 7 times 12, it ends up being 84 degrees. So it's not bad what I did, right? And then you basically do the same thing. Redwood City would look like this. Atherton might look like this, and so on. I'm obviously just kind of winging it here. Obviously, it's not very close. Okay, Half Moon Bay is way too big, but you get the idea. And actually, usually you'll never make a pie chart by hand. It's always computer software that kind of does that for you. Okay, not a big deal. But notice again, it can only be done with categorical data. And the idea is, why is the Menlo Park pie here and the San Carlos pie is over here? Makes absolutely no reason. For categorical data, that can be in any order really you want. Okay? And let's actually stop this lecture right there, and I'm going to go on to the other ones later on, because all the other ones have to do with quantitative data.